Okay, this is MC underscore 3, the third problem in this series. MC underscore 3, 4.3. This circuit is somewhat complex looking, much more frightening than it really is. I think there is more bark to it than bite. We will see. Okay. And we have, this is the current source in an amount of 2 amp, and the voltage across this is shown as V sub 2. Then we have 7 ohm resistor here, and this fellow is 5 ohm, and this current here that's flowing here is I sub x. Here is a voltage source, minus on the left and plus on the right. Going towards this node and extending here, there is another resistor. Here is a diamond and another resistor. This diamond has plus and minus 3 V sub y as the output. So this is a voltage dependent voltage source. 4 ohm is on this side. This is what is I sub 2 is shown, and this resistor is 3 ohm. There is plus and minus V sub 1. Okay, and we continue this path here. We have another fellow here, diamond, accompanied by a resistor here, and this is going here, 6 ohm, and this is a current source 2 times I sub x. 2 ohm is this fellow, and we have another, wait a minute, there's a resistor here and the supply, and this fellow is minus here and plus here, and this is 1 ohm. Hang on, this thing is the voltage source 10 volt here. Okay, this is plus and a minus V sub y. This source is 6 volt. So we have nodes here, and 2 amp plus minus V sub to 7 ohm, 5 ohm, I sub x, minus plus 10 volt. This is mesh number 1, I sub 1, and 5 ohm Ix plus minus 3 Vy, 4 ohm I sub 2, 3 ohm plus minus here. This is mesh number 2, I sub 2 flowing in the mesh, this is 2, and let's say 2 ohm plus minus V sub 1, 2 Ix, 6 ohm. This is mesh number 3, I sub 3. It's pretty tricky to write those things. V sub y is 6 volt, 10 volt, and I sub 4. Having got all this shown in the circuit, our goal is to come to the matrix equation representing Ohm's law. Let's go back and check the circuit carefully. The diamonds have I sub x, V sub y quantities as such, so we have to express them in terms of the mesh current. Okay, so I sub x is the current that's going along the leg that has 5 ohm resistance. And obviously along that branch we have two competing current, I sub 1 and I sub 2. I1 is along the direction of Ix, so we would see there's the competition, and I sub 1 prevails over I sub 2 to give a balance of I sub x. What else? We notice that V sub y is the voltage across the resistor of resistance 1 ohm, and the current that's flowing there is I sub 4, but in the opposite direction, meaning V sub y is 1 times minus I sub 4th, which is minus I 4th. So that is determined as well. This is I 4th, folks. Okay, so I 4th. Alrighty. Now, when you look at V sub 1, V sub 1 is the voltage across a 3 ohm resistor. So we have the resistance, we need to figure out the current that's flowing along this leg. Notice plus of the V sub 1 is onto the left, meaning I sub 3 prevails over I sub 2 to determine V sub 1. So V sub 1 is resistance 3 times the balance in current, which is I3 minus I sub 2. Okay. What else is happening? I sub 3 is the same as 2ix. So I sub 3 is 2 times ix. And since I sub x is I1 minus I2, we can plug that expression, resulting what now? 2I1 minus 2I2. So we can simplify this. Okay. Such as 2I1 2I1 minus 2I2 minus I3 equals 0, right? So if we wanted to have all the i's, I1 through I4, we could express this, and let's put that in a box as we always do. Namely, we would have 2 times I1 plus, we would have minus 2 times I sub 2, then plus minus 1 times I sub 3 times, well, I sub 3 times I sub 3 plus 0 times I sub 4 equals 0. Okay, so this fellow will go and sit in the box. And we also notice from the mesh number 1 that I sub 1 is primarily equal to 2 amp. So this is from mesh number what now? Mesh number 1. We see I sub 1 is 2 amp, which could be expressed and put in the box so as to allow us to show them in the matrix with all the i's, such as this would be I1 is 2 amp, meaning we have to multiply 1 times I sub 1 plus nothing times I sub 2 plus nothing times I sub 3 plus nothing times I sub 4 is equal to 2. So we have two expressions ready to go. We need two more. All right. So let's look at mess number 2. So let's use our good old KVL. So in mess number 2, KVL will yield the following. If we start going down the circuit, where we have the resistance 5 ohm, then we have the voltage given by 5 times I2 minus I1 using the house rule. I2 prevails over I sub 1. We continue, then we see plus 3 Vy and plus 4I2. Then we are on the last piece, which is 3 ohm resistance. So we have plus 3 using house rule. I2 prevails over I sub 3. So I2 minus I3 equals 0. So we can expand this fellow. Let's do that. 5I2 minus 5I1 and plus 3Vy. The Vy is minus I4. Remember that. So minus 3I4, then plus 4I2, and then plus 3I2 minus 3I3 equals 0. So we're ready for another box, folks. Let's try this box. So we have things to go in the matrix. So in this box, let's start with the I1. We have minus 5I1. So we will have to put minus 5, first of all, times I sub 1. And then let's say, with the I2, we have 5I2 and 4I2, that will be 9I2 plus 3I2, that makes 12I2. So we have plus 12I2, that's times for I3. We have how many I3? Minus 3I3, so we put plus here and then minus 3I3. Now it's the turn of I4. Looks like we have simply minus 3I4, so let's put in the plus, and sorry about that, excuse me, 3I4 here, okay, equals 0. So this is going to the box. Wait a minute, okay, already, so it's kind of narrow here. So we have 3 boxes ready to go, 1 more box yet to come our way. Let's flip the page. Good deal. So this is the time to look at another mess. So we're going to pick mess number 4. That would have voltages, that's good. We're skipping mess number 3 because mess number 3 has the current source on the path. We don't want to go there because we're going to use KVL this time. Mess number 4, folks. Mess number 4. And we are going to use KVL. So that will yield, we're starting at the plus where we have the 6 volt source. So we have 6 to start off. Then notice we have minus V sub y. Okay. And then continuing the path, we're saying minus 10, then plus 2 house rule. So I4 prevails over I3 across the 2 ohm resistor, giving us a balance of 2 times I4 minus I3 equals 0. So we again need to remember V sub y is simply minus I4. So this is telling us 6 minus times minus plus I4. It's time to expand the parenthesis. So plus 2I4 minus 2i3 equals 0. So it's time for another box to put in the matrix. Let's go here. So this one would have, let's take a look at I sub 1 is none here. No I sub 1. So 0 times I sub 1. How about I sub 2? No I sub 2. So plus 0 times I sub 2. And then how about I sub 3? We have minus 2i3, meaning you put a plus here, and minus 2i3. What else? Then we have plus with the 2i4, i4. So that's 3i4. So 3i4 equals, when we move the 6 minus 10 is minus 4, and if we move to the right side, it's a plus 4. There you go. That's the last box. So we got all the boxes we need. So our Ohm's law would appear in this matrix as following. Remember that we can put any of these boxes in any row. It doesn't change a thing. So we could write the matrix in this manner. Let's see here, this, and here, and here. We're going too narrow there. Okay, let's see here. So let's start with the most recent box. So we have 0, 0, minus 2, and 3. I sub 1, I sub 2, I sub 3, I sub 4. The top line has 4 on the right side. Okay, and then realizing we have I sub 1 is 2m, we have 1, 0, 0, 0 is 2. So that's the second row. Okay. Next, we can put the other one, which is 2i1 minus 2i2 minus i3 equals 0. So that will give us 2 minus 2 minus 1 and 0 is 0. So the last row is the one with the minus 5. So that will give us minus 5i1 plus 12i2 minus 3i3 minus 3i4 is 0. So minus 5, 12, minus 3, and minus 3 equals 0. So this is your matrix equation. You're looking at an impedance matrix, which is the coefficient matrix, times the current vector equals the source, which is the voltage vector. Namely, this is our Ohm's law in matrix form. This is the conclusion of the problem. Hope you enjoyed it. Take care. Bye.